This video is going to cover Chapter 4, Section 4, which is trigonometric functions at any angle. So basically we are taking what we learned about those trig functions and we're expanding it beyond just our unit circle. Here's the overlap of your typical theta angle and then the point that's on its terminal side, which is the xy. So if you have r being the radius and it's equal to the square root of x squared plus y squared, which is what would happen if I had r squared equals x squared plus y squared and square rooted both sides, then that radius is the distance from 0, 0, which is your point at your center, to the xy shown in these figures. So if I'm looking at these are angles that stop further outside of my unit circle. What's changing between these and what we've done before is that this point is no longer 1. So the furthest point out is no longer 1, which means that our x and y is going to adjust, and our trig functions are now going to adjust. So because sine is opposite over hypotenuse, if I zoom in on this function here, and this point is xy, I can draw this triangle where x is my horizontal distance, y is the vertical distance, and the hypotenuse is r. And if I want to find the sine of this angle, opposite over hypotenuse would be y over r. If I wanted to find the sine, x over r would be adjacent over hypotenuse, and if I wanted to find the tangent, y over x would be opposite over adjacent. So that's basically where all of these come from. Instead of it just being y because the radius was 1 in our unit circle, we now have to account for the radius not being just 1. So you put the y over the r for the sine, the x over the r for the cosine, the y over x for the tangent, r over y for the cosecant, r over x for the secant, and x over y for the cotangent. As you go through the different drawings on the bottom here, all that changes is the location of your angle. So I went from first quadrant to second to third to fourth, which means that in my second quadrant, my x is going to be negative, my y is positive. The r will always be positive. If you're in the third quadrant, the x is negative, the y is also negative, but again, the r is always positive. And in the fourth quadrant, the x is positive, the y is negative, again, the r is always positive. Here's a quick review of your degree and radian measures. Remember, positives move counterclockwise and negative move clockwise. These are all the ones from 0 to 360 or 0 to negative 360. And then also in radians. Trig functions of the quadrantal angles. So if we draw our quadrant angles out, we have 0, pi over 2, pi, 3 pi over 2, and back to 2 pi. We know the coordinate points here are 1, 0, 0, 1, negative 1, 0, 0, negative 1. And from these, you can find the sine, the cosine, and the tangent of all these angles. At 0, the sine would be the y, which is 0. The cosine is the x, which is 1. And the tangent is y over x, 0 over 1, which is 0. At 90, at the top, the sine, which is the y, is 1. Cosine is 0. And the tangent, 1 over 0, would be undefined. At 180 on the left, the sine, which is the y, is 0. The cosine, which is the x, is negative 1. And the tangent, 0 over negative 1, is 0. And the last one, 270 on the bottom. Now you're moving down 1, so the sine, which is y, is negative 1. The cosine would be 0, and negative 1 over 0 would be undefined. So these you can know by just knowing those 4 points. If you want to memorize them, you can too. But if not, hopefully you can just access them from knowing those 4 points. All right, example 1 says determine the exact values of the 6 trig functions of each angle theta. So what exact means is we're not rounding these. We're going to leave these as reduced fractions. If we can reduce them, obviously we reduce them. And if we can't, we leave them just as an original fraction. So in A, this is a point 4, 3, which means you're moving to the right because that's your x, 4. And you're moving up because that's your y, 3. This forms your right triangle. And the radius is the side that connects them, which would be the hypotenuse. Hopefully you remember that this would be one of your Pythagorean triples, and so 3, 4, the missing side is 5. If you don't, you can always use the Pythagorean theorem to find it. Now we need to find the 6 trig functions. So sine of theta, cosine of theta, tangent of theta, and then cosecant of theta, secant of theta, and cotangent of theta. Sine is opposite over hypotenuse. This is theta. Opposite would be 3. Hypotenuse would be 5. Cosine is adjacent over hypotenuse. Adjacent is 4. Hypotenuse is 5. Tangent is opposite over adjacent. Opposite is 3. Adjacent is 4. And then to get your reciprocal functions, simply flip the originals. So secant is the reciprocal, cosecant, sorry, is the reciprocal of sine. This would be 5/3. Secant is the reciprocal of cosine. This would be 5/4. And cotangent is the reciprocal of tangent, 4/3. Now let's look at B. This time my point is -8, +15. So you're moving left 8, there's your -8. You're moving up 15, +15, and then the radius that connects them makes the hypotenuse. 8, 15, 17 is a triple. Again, if you don't know it, then you can use the Pythagorean theorem. And then from here, sine theta, cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta. So even though this angle is out here, it would be the same trig functions as what's happening inside your angle here. You have to use this reference angle inside to use the properties of the right triangle to get your trig functions. So the sine of theta, again, here's theta, opposite is 15, hypotenuse is 17. The cosine is -8 over 17. The tangent is 15 over -8. The cosecant is 17 over 15. Secant, -17 over 8. And cotangent, -8 over 15. Example 2 says the point is on the terminal side of an angle in the standard position. Determine the exact values of the 6 trig functions of the angle. So the only difference between these and what we just saw is that these don't give you the drawing. You got to do that first. So -4, 7, if you think about starting at your origin, would be back 4 and up 7. And the hypotenuse could be drawn as the radius to connect them. This time there's no triple, so I have to use a squared plus b squared equals c squared. I don't have to worry about the negative because when I square it, it will always turn positive, but if you want to take it, you can. So a squared plus b squared equals c squared being the radius. 28 plus 49 equals c squared. 77 equals c squared, and c equals the square root of 77, which just breaks down to 7 and 11. Neither of those double. So I'm going to keep the radius as the square root of 77. Now I'm going to find all 6 trig functions. Sine of theta, opposite, so theta is here. Opposite is 7, hypotenuse is square root 77. This gets rationalized to 7 square root 77 over 7, 77. And then 7 goes into both those. This becomes square root 77 over 11. Cosine of theta is -4 over the square root of 77. And this time it gets rationalized to -4 square root 77 over 77. Tangent, opposite over adjacent, much easier. Cosecant, I'm going to go back up and flip sine, but I'm going to do it before we rationalize it. So I'm going to do it from this point here. So it's square root 77 over 7. Secant of theta, I'm going to flip it again before I rationalize it. So negative square root 77 over 4. And cotangent, I'm going to find the reciprocal of tangent, so -4 over 7. Now look at B. So 3, -4 means forward 3 and then down 4. So +3, -4. My triangle looks like this. Theta is in this corner, and this is one of my triples. 3, 4, the missing side is 5. Sine of theta is negative 4/5. Cosine of theta, 3/5. Tangent of theta, negative 4/3. Now the reciprocal functions, the reciprocal of sine, which is cosecant, is negative 5/4. Reciprocal of cosine is secant, 5/3. Reciprocal of tangent, cotangent, negative 3/4. All right, so the signs of the trig functions as you move around your circle are based on the x and y values. So in quadrant 1, all of the functions are positive. In quadrant 2, because the x is negative and the y is positive, sine and cosecant are positive, but everything else is negative. In the third quadrant, because both the x and y are negative, tangent and cotangent are the only ones that are positive because those are going to be the negative over the negative. And then in the fourth quadrant, cosine and secant are positive because the x is positive but the y is negative. So cosine and secant positive, everything else negative. An easy way to remember this is by the acronym all students take calculus. So if you move counterclockwise around in the order of your quadrants, the A comes first for all, the S comes second for just sine, which leads to cosecant. T comes third, which means tangent and leads to cotangent. And the last one is C, which is cosine, which leads to secant. So again, if you start in the top right corner and you go counterclockwise around, or the order of the quadrants, with all students take calculus, you can remember that order. There's some other suggestions here. All snakes tease chickens, and a smart trig class like you guys are. So example 3 says, name the quadrant in which theta lies if cotangent of theta is greater than 0 and the sine of theta is less than 0. So if we just draw that quick, all students take calculus, and I'm looking for where the cotangent's greater than 0. That means tangent would have to be greater than 0. And sine is less than 0. By sine being less, I can rule out quadrant 1. And I can rule out quadrant 2 because in both of those, sine is positive or greater than 0. So then I go to the next part, which if tangent is greater than 0, that only happens in the third quadrant. Tangent is not positive in the fourth quadrant. So the only one that works for both of these is quadrant 3. Example 4 says, given that cotangent of theta is negative 4/3 and sine of theta is greater than 1, find the following. So I'm going to go back to setting up a triangle. I'm going to draw a triangle. I'm going to put theta in the corner. Now this time this might not make sense with the direction of theta based on the positive negative sign. So we're just going to worry about where it would be, but not worry about how to draw it that way. Because cotangent is negative 4/3, and that can be written as negative 4/3, 4 over negative 3, we don't know which of these sides to make negative yet. So cotangent would be adjacent over opposite. I know the adjacent side is 4 and the opposite is 3. Now to figure out which one of those is negative, we look at the second piece of information they give you, which says sine is greater than 0. For sine to be greater than 0, y would have to be greater than 0, which tells you that of those two parts, 4 gets the negative. Then, this is a Pythagorean triple. I know the radius is positive and it's 5 because 3, 4, 5. From there, I can find the sine. If you're having a hard time looking at this because it doesn't make sense with the direction and the negative and the positive, you can always draw this backwards. So if it's negative 4, then the negative goes this way, positive 3 goes this way. Now your radius is here, which is 5, but theta is still in that corner, so the relationships are still the same. Sine would still be opposite over hypotenuse, which would be 3/5, which should be positive because it matches what we got given. The cosine would be negative 4/5. The secant is the reciprocal of cosine, which is negative 5/4. And the cosecant is the reciprocal of sine, which is 5/3. Example 5 says the terminal side of theta lies on the given line in the specific quadrant. Find the values of the 6 trig functions of theta by finding a point on the line. So these initial notes are missing the quadrant. We're going to add this in and say that the terminal side is in quadrant 1. Now I'm going to pull in a graph so that we can graph this really accurately. So to graph y equals 3x, my y-intercept would be 0, so I'd start at 0. And my slope is 3, or up 3 and over 1. 1, 2, 3 over 1. So the line would be like this, and it's saying that the terminal side of this, it lies on that given line. So if I zoom in on it, I can actually use this as the terminal side of my angle. And because I know that it's gone up 3 and over 1, I know the horizontal distance is 1 and the vertical distance is 3. So now I can focus on this smaller triangle in which this terminal point would be 1, 3. Again, horizontal distance would be 1, vertical would be 3. So when it says find the values of the 6 trig functions, all I'm missing is the hypotenuse of this triangle. I can do a squared plus b squared equals c squared. 1 plus 9 equals c squared, and c squared is 10. So c equals the square root of 10. Now I've got all 3 side lengths, 1, 3, and root 10. And from there, I can find my 6 trig functions. Sine of theta is opposite over hypotenuse, so 3 over root 10, which becomes 3 root 10 over 10. Cosine of theta, which is 1 over root 10, which rationalizes to root 10 over 10. Tangent of theta, which is 3 over 1, or 3. And then the reciprocal functions. Cosecant, I'm going to go back to before I rationalized, so root 10 over 3. Secant, again, go back to before you rationalize, so root 10. And cotangent, the reciprocal of 3 over 1, which is 1/3. So if it had said something like quadrant 2 here, well, sorry, not quadrant 2, that wouldn't work. If it had said quadrant 3, then I'd be using this triangle down here where I would have gone down 3 and left 1. My slope would still be 3 over 1, which is consistent with what I got from my line, but I would be using the negative values. Okay, example 6 says evaluate the trig function of the quadrant angle if possible. So we just want to remember what our quadrant angles are: 0, pi over 2, pi, and 3 pi over 2. This would be 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So when it says the sine of pi, I would go to pi, which is here. Sine is the y value, so this is 0. And this 2 should be shifted over. So this should be cotangent of 3 pi over 2. 3 pi over 2 is down here. Cotangent is your x over your y. 0 over negative 1, which is also 0. So where it says if possible, if I had asked for the tangent at 3 pi over 2, I would have gotten negative 1 over 0, which would have been undefined. That's what that means. The next part of the section is covering reference angles. So a reference angle of theta is the acute angle theta prime, which is what that little apostrophe is read as, formed by the terminal side of theta and the horizontal axis. So this is basically saying that the reference angle is the measurement of an angle that's formed from the x-axis to that angle. To find the reference angle, you're going to find the difference between the angle and the x-axis. So if that angle is in the first quadrant, then the reference angle is actually equal to theta. Because if I subtract 0 from it to get the distance from that angle to the x-axis, it would remain as whatever it initially is. So in the first quadrant, the reference angle is equal to the angle. If it was 30 degrees, it's 30 degrees, 60 degrees, 60 degrees, 72 degrees, reference angle is 72 degrees. In the second quadrant, so any angle in my second quadrant, I would find theta prime, or the reference angle, by subtracting the angle from 180. So 180 minus whatever theta is. for example, if I had 100 degrees here, then 180 minus 100 would mean my reference angle is 80 degrees. It's always the distance from the angle itself to the x-axis. In the third quadrant, anything over here, the reference angle is found by doing theta minus 180. So you just reverse that. So in this case, if I had something like 200, I would do 200 minus 180, and I'd get my reference angle would be 20 degrees. And in the fourth quadrant, your reference angle is going to be found, so any angle here, by subtracting it from 360 degrees. So reference angle equals 360 minus theta. And again, for example, let's say it was 300 in here. I would do 360 minus 300, and I would get my reference angle is 60 degrees. So notice that all of these reference angles, no matter where you are in your circle, are always equal to or less than 90 degrees. So you're never going to get an angle that's bigger than 90 degrees. Must be less than or equal to 90 degrees. So example 7 says find the reference angle theta prime and sketch the initial angle theta and theta prime in standard position. Notice that these are in radians. So if you take what we just talked about in the first, second, and third quadrant, in the first quadrant, it doesn't matter if it's in radians or degrees, it's going to stay that way. In the second quadrant, we were subtracting it from 180. So in the second quadrant, 180 would be the same thing as pi. So I would do pi minus the angle. In the third quadrant, we were subtracting the angle minus 180 degrees. So this time we're going to do theta minus pi. And in the fourth quadrant, we were doing the angle subtracted from 360 degrees. So in this one, we'll do 2 pi minus theta. So the first thing you do is figure out in which quadrant you're located and then go from there. So 2 pi over 3, hopefully we're getting the hang of this now. That's bigger than a half, but less than 1, which means this goes in the second quadrant. And in the second quadrant, we would do pi minus 2 pi over 3. And this becomes 3 pi over 3 minus 2 pi over 3. And my reference angle is pi over 3. Then I go to B, 9 pi over 2. So this one's not on my unit circle. It's too big. This is the same thing as 4 and 1/2 pi. So because you're going around your circle 2 total times, 1 time is 2 pi, around again is 4 pi, then I only have to go to 1/2 pi to find the angle. And because that's on the end of the first quadrant, my reference angle is just that, pi over 2. Example 8 says, find the sine, cosine, and tangent of the angle without a calculator. So now we're going to talk about how you can do this with the reference angle. So instead of knowing your full unit circle, you can figure out what the reference angle is for 5 pi over 4. So I know that this would be just past pi. The reference angle there would be 5 pi over 4 minus pi, or 4 pi over 4, which is pi over 4. So knowing that, you can know your point, which is root 2 over 2 and root 2 over 2. And then because we're in the third quadrant and all students take calculus, I would know the tangent and the cotangent are positive and everything else is negative. So when I go to sine, which is the y, I would do negative root 2 over 2. Cosine would be negative root 2 over 2. Tangent would be root 2 over 2 over root 2 over 2, which is a positive 1. And then cosecant, I would flip negative root 2 over 2, and I would get 2 over root 2, which gets rationalized negative to root 2 over 2, or just root 2, and that's negative. Secant would be the same thing, negative root 2, and then cotangent, reciprocal of tangent, which is still 1. So you can use your actual angle on your unit circle, or you can use your reference angle, and then the all students take calculus to figure out your sines. Example 9 says, use the calculator to evaluate the trig function, and then round your answer to the 4 decimal places. So we're back to the same type of example we've been doing the last couple sections. Because this is cotangent of 4.3 and there's no degrees on there, this would be in radians. I would do 1 divided by the tangent of 4.3, and again, making sure your calculator is in radians. So 1 divided by the tangent of 4.3 is 0.4375. For B, secant of 213, now we're in degrees, so 1 over the cosine of 213 while in degrees is negative 1.1924. Example 10 says find 2 solutions of each equation and give your answer in degrees and in radians. Don't use a calculator. So this is almost the reverse that we're going to get to at the end of the chapter, which is 4-7 inverse functions. We're kind of baby stepping our way there. So to best get these answers, I'm actually going to pull in the completed unit circle so we can see it. Okay, so for A, we're looking for an angle in which the sine of that angle is 1/2. So think about the fact that we're looking for an angle measurement. It actually says to give it in degrees and radians, so we're going to get it in both ways. And we're looking for one in which the sine is 1/2. If it's the sine, we're looking for where our y value is 1/2. So if you move around your unit circle and look for where y is positive 1/2, it's going to happen here and it's going to happen here. So the angle that matches that would be 30 degrees or pi over 6 and 150 degrees or 5 pi over 6. So there's 2 different angles in both degrees and radians for that answer. If you look at B, it says the sine of negative 1/2. So now we're looking for where the y is a negative 1/2. And again, as you move around your unit circle, you'll find that y is negative 1/2 down here at 7 pi over 6 and here at 11 pi over 6. So we'll write those angles in both degrees and radians, 7 pi over 6 or 210 degrees and 11 pi over 6 or 330 degrees. Last example is your word problem. So it says the displacement from equilibrium of an oscillating weight suspended by a spring is given by the function y of t equals 2 times the sine of 6t, where y is the displacement in centimeters and t is the time in seconds. Find the displacement when A, t is 0, B, t is 1/4, and C, t is 1/2. So what's happening is you have a spring that's being taken down and up and then springs back up and then comes back down and then comes back up. And so the function that's formed by that is that y of t equals 2 sine 6t. So if you first want to find what the displacement is when t is 0, you just have to take that t and replace it with 0. So 2 sine 6 times 0 is 2 times sine of 0. So now this is in radians, so we're going to say what, or it doesn't matter actually if it's in radians or it's in degrees. What is the sine of 0? And we know that the sine of 0 degrees or 0 radians would be 0. So 2 times 0 is 0. And hopefully that makes sense. If it hasn't been displaced at all, if it hasn't even been pulled, then the displacement should be 0. So when t is 0, the displacement, or y of t, equals 0. Then we're going to repeat that whole thing for 1/4. So 2 sine 6 of 1/4 is 2 times the sine of, this is 2, this is 3, 3 over 2. If this was an angle that you could find on your unit circle, so if that was, say, sine of 3 pi over 2, then I would find the exact value using the unit circle and then multiply it times 2. But because this 3 over 2 is not something that's on our unit circle, we're going to use a calculator. So I'm going to use the calculator to find the sine of 3 pi over 2. Again, these should be in radians. Or sorry, 3 over 2. And the sine of that is 0.9975. Multiply that times 2. And I get 1.99498. So we're going to say 1.9950. So when t equals 1/4, the displacement is 1.9950 centimeters. Now I'd go on to C, which is 1/2. So I get 2 sine of 6 times 1/2. And I get 2 sine of 3. Again, if that was something like 3 pi, I would find the exact value of it. But because it's 3, I'm going to use the calculator. The sine of 3 is 0.4111. And I'll multiply that times 2. And I get 0.2822. So the displacement at 1/2 is 0.2822. When you're comparing that with B, that means basically that spring is on its way back up to its original spot. All right, that wraps up the notes for section 4.4. You can use the rest of the time to work on your assignment.